So today we will finally start working with cycles. I will always show you a few ways to do stuff also with Eevee because cycles is pretty hard on your computer as I mentioned before. But first of all, what's the difference between Eevee and cycles? Eevee is a non-physical based render engine and cycles is a physical based render engine. So the main difference is that physical-based render engines are working with simulated light rays. So they're much more physical accurate and therefore we can show a lot of more lighting details. And this is a chapter from my thesis. And for example, global illumination is this year. We have a green plane, and when light hits it, it's reflecting green light. This is a physical-based render engine, so it cycles. Up here, you can see it's not happening, and this is because Eevee is just like faking that it's using light rays. Yeah, there are a lot of examples for this. For example, this is the glass material in Eevee, and this is the one in Cycles. So what Eevee actually does is it's taking a picture from the environment and then distorting it on the glass object, while Cycles actually goes the long way and the light waves are penetrating the object and they're getting refracted and so on. So normally you would think like cycles is always better. This is not always the case. If you're working in a very graphical way, like if you do toon shader, it's much better to use Eevee because your workflow will be much faster. Yeah, this down here is a good example. These are splash screens from old Blender versions, and here you can see the Eevee version here completely fails compared to the Cycles version because we have a lot of refraction, we have subsurface scattering on the skin. So the main goal of this scene is to be very realistic, and therefore Eevee is not the best choice. But down here we can barely see a difference between Cycles and Eevee. And actually these lens flare and blur effects, you don't have them in Cycles. And yeah, this picture in Cycles here would probably render around 15 minutes, while you can render this Eevee image, depending on your computer, more or less instantly. So this is it about the main concept of these render engines.
Okay, sorry for the audio in the first part. I prepared this. It's again a sphere with just a simple displacement, as you already learned. And I showed this in the last class. We're going to shading, and then we're going to world. Normally, you always work in the object field. We come to this later, but for now we're going to world. And there are two ways of doing this, actually three, but I will first show you the general setup and then we're gonna go over the different versions. So you're gonna look for environment texture. I prepared a few of these noise patterns. I'm gonna go for the lines because we can make them seamless. And hit Ctrl T. I hope you all activated the node wrangler, and this will, yeah, with this we can later refigure where the texture is sitting. So now we need to mix shader, plug this here, this comes here. And the last thing we need is the light path, just put it here, and is camera array is gonna be our factor. And now we can see we hooked this up the exact wrong way. Okay, let's put this black. So what we did is we can see the reflection from our environment texture in our object, and we blend it out everywhere else. So what can we do now? Let's go to object and decrease the roughness. And for example, let's make it metallic. And you can see these spots which look low resolution. This is not due to your picture being rowless, this is due to the subdivision count. So the more we increase it, the better our resolution gets. Yeah, so metallic materials are reflecting a lot, of course, and also non-rough materials are reflecting a lot. But we're here to see the big difference between Eevee and Cycles, and for this I'm gonna use a glass BSDF. Actually, you could just like increase the transmission and put the roughness to 0, but let's use the glass BSDF instead. So we can see this beautiful reflection, because as I told you, Eevee is not doing the whole light refraction inside of the glass, it's just like refracting the environment. So if we switch to Cycles, we can see now we actually have that beautiful glass refraction. And let's go here again, and let's make it metallic again, and let's bring up the roughness a little bit. So you can play a little bit with these settings. I'm not sure how much I should explain this. Okay, like metallic is important, specular, leave it alone, like focus on metallic, roughness, and transmission. If we put metallic to 0, transmission up, and roughness completely low, this is the exact same as the glass BSDF. The glass BSDF also have a roughness, and the IOR, the index of refraction, 1.45 is glass, and also we down here have the IOR, so let's use this one, and IOR of water is 1 as far as I know. It means how much the light gets refracted. You can experiment a little bit with it. Okay, so now we learned how to render this stuff, but I actually promised you to show you 2 other ways to do this. So this is an environment texture, and let's just watch at the environment texture. So it's a sphere, and yeah, our lines are mapped on the sphere. What we can also do is we can take an image texture. We're loading the same thing again, and let's preview it, and we see nothing. So we actually have to press Control T again, and then plug the generated here. And you can see now it's actually a perfect loop. Let's check this again. And actually also, if I rotate these, like we could get the same result. The important thing is you have to remember, if you use image texture instead of environment texture, you have to use the mapping ungenerated. And next thing we can do is we can actually animate this. So it's the same concept with the animated texture. You tip your frames, you tip auto refresh, and it's animating. Let's connect this one again. And you can see it's changing. Let's go back to Eevee, because in Eevee it will only update if you pause, but there is actually a workaround for this, because if we rotate it, it will update the background every frame itself. And let's preview this one again. And you need to find like one angle which is working good, but it actually doesn't matter. So let's take this one, take this plus down here, pull this up, go to your not dope sheet, we want to the timeline, we go to frame 0, and you hover over the rotation field, you press I, and you have a keyframe. Now we go back here, 360, I again, and now if we connect this again, the background is updating. I quickly built this shader and it's simulating dispersion. Like, this is a rather inaccurate way to do it, and I will shortly explain it, but I will also link a more advanced tutorial on simulating dispersion in Blender cycles this week. So we have our light colors, RGB, and we have a slightly shifted IOR value in all of them, and in the end I don't use mix shader, I use edge shader. So I'm just adding these shaders together, and therefore the light waves get refracted in a little bit different IORs. So we have our object, and now we want to export it. One thing which is pretty important is the resolution. If I crank up the resolution crazy high, like, you will not do this because your computers will not be able to calculate it, but if you would do it, you have to keep in mind this is a physical simulation. So if you scale it up, you also need more light. Like, this is a little bit more tricky about cycles. You always have to keep in mind size of things. So if you're doing a preview, it's not only important to decrease the samples, it's also making sense to decrease the resolution. And you can decrease or increase stuff by using this as a calculator. So I can divide it by 2 or can multiply by 2. Both is possible. Let's go over these settings step by step. we are calculating right now with the CPU, Central Processing Unit. If you have a Tower PC, definitely go for GPU compute, which I'm doing because I have one. This whole viewport stuff is not too important. Like the only really important thing are the max samples here, because 4,000 samples will calculate forever. The best thing is if you want to do a final render, I keep the 4,000 and I go and render image. And okay, this is glitching out right now, but I can see up here I'm having like roughly 40 samples of 4,000 and it's looking quite good. So I can calculate for myself, okay, if I want really good resolution, probably I'm gonna go for 250. Now I went back, but it's still rendering down here. If you want to quit it, just press escape or exit down here. So let's go for 250 and I'm gonna choose our tutorial 5 folder and call it ref_001. I actually made a mistake while recording before. So you all did render a picture and then you saved it by hand, and if you want to save a single frame by default, it's actually not the best way, but we are at frame 55. So in the frame range, we type frame start 55 until end 55. And let's do these really low. And then basically you render a 1 frame animation. And this way it's saving by default. One other thing you will see, it's a bit grainy here, but we're denoising now, and the denoising is calculating out the noise. So yeah. And here is our single frame saved by Blender directly. One other thing you can do is, let's crank this up to 4095 again, and let's just, okay, we're going to render image again, and you forgot to change your samples. You're satisfied with the result. In that case, you can stop the rendering job and then you can save it. Okay, so much for rendering. In the end, I want to talk about why I like this method so much. And basically it's because you can generate a shit ton of different results in a really short time. So we're changing the object and also we're changing the background in which the object is reflecting. And so you just need to scan your timeline and your angle for something you like, render it out, and you can generate like 50 nice images in 1.5 hours basically. So yeah, this is important. I showed you like animating techniques, but you don't have to render an animation with it. Like, this is just a tool for you to generate a lot of different output in a really short time. So as always, have fun learning, and I'm curious for your results. See you next week.